Hello YouTube, Vintage Stereo Restores. You wouldn't believe this. First it was my cell phone going off with several messages. And then it was somebody at the doorbell. So now I think I have the piece to do this. KA-2000 Part 9. I've started this board here, got the phono board back in, it works like it should. This one has the most capacitors and the highest parts density. And you'll notice this in early Japanese stuff. Before integrated circuits, they really have it tight together on the board. It can be a bit of a challenge to work on. Then you start off, so this is the left channel. I started off here. It's a mirror image. First cap I take out. It's a 1 microfarad where there's supposed to be a 10 microfarad. I'm like, okay. Look at the schematic on the Kenwood thing. And, oh, it is a 10 microfarad. But down here, on this diagram, it's a 1 microfarad. Like, okay, well, I have a newer schematic. This is a KA-2000A. It was like the silver face version. There are a few minor changes to it, but basically the same boards. It's a 1 microfarad with a 100 picofarad cap between the base and collector of that transistor there, which I've added in. Right there. On this side you see it's not there. So this is not a new thing. You're going to run into this if you work on stereos, and it manifests in different ways. If it's a capacitor like this and you see, well, they substituted a lesser value part, probably cost savings. It might even be a running substitution because they didn't have 10s in the parts bin. Put in the bigger cap. It's only going to help the sound. Now, going to a 10 microfarad from a 1 is quite a change. 100 is too much of a change. Now I put some headphones in, listened to a couple sources with this, and there is a little bit of a difference. This side here, the bass is just a bit more distinct. Could be because it's a fresh cap and a fresh transistor. Could be the difference in value. But I'd go with that one. Where you're going to see this quite a bit is in transistors. So this unit here on the schematic says 2 SD91s, and it shows C458s here and here. But then I've seen them with other transistors. And you look it up and it's some obscure 2SC7 something. And you look it up and it's actually a lesser part. I ran into this big time on a Yamaha CA810 a couple years ago. It was amazing. It was an original unit. It didn't have a bunch of substitutions. But at the factory, the parts they were using, not one transistor matched the parts list or the schematic. I just couldn't believe it. Then I thought, you know what, I've run into this before with some Pioneers. You've got like, you'll find out you've got like about the third version of it. And sometimes it means a lesser part or slightly different part. In the case of these, and with way transistors are now very inexpensive, you can substitute a transistor in there, and I've given values on another one, but this 2SC984, I actually put in a 2N2222 or 2219, which is the same transistor but in a heavier metal case. It actually has better current handling, lower noise, very similar HFE or beta. It's actually an improvement. So this is kind of the way you have to look at it. You'll come across and you'll go, oh, look at these diodes. One's bad. And it's an FR1. And you think, well, an FR1, gee, in that circuit, that just might not be the right value. Well, put in an IN4007 that has 1,000 volt inverse peak voltage handling. Like, you can improve the part, no problem. You can increase on these electrolytics, increase the capacity by about 50%. And you can take the voltage, and I've talked about this before with These are all different voltages in here. There's some 16s, there's some 25s, there's some 35s, there's some 50s. I buy them all as a 50 because now a 50 volt is really same price as trying to source a 16 volt, because they make a million billion of the 50 volt ones. So in this case, and you're going to come across this, for instance, these two 10K pots here. On some of them that I've pulled out 5K, even though on the schematic it's a 10K. And it worked. It worked for like 50 some years. So anyway, I'm going to motor on with this, and I'm just going to do this channel until I reach the center line, then do this channel until I reach the center line, replace the protection transistor and caps, and then after that set the bias and everything. So we'll meet up around that time when all the caps and transistors are on this board. We'll set the bias, we'll just take some measurements, see how it's working. Anyway, thanks for watching and listening.